In this lesson, you'll learn to solve quadratic equations by using the quadratic formula and use the discriminant to determine the number and types of roots of a quadratic equation. I'm going to give you a real quick overview of how the quadratic formula is developed using the completing the square method that we had in the last lesson. So we have a basic quadratic in the form ax squared plus bx plus c equals 0. And when we do completing the square, we don't want a coefficient in front of our a other than 1, so I divided both sides by a and subtracted c over a from both sides. Now I need to complete the square, so I'm going to take the coefficient of x, and I'm going to go times a half, since it's already a fraction, squared, and square it, so I've got b squared over 4a squared. So my completed square is going to be x plus b over 2a squared. And over here, I wish I had a common denominator. So if I multiply that first fraction times 4a over 4a, I get 1. So now in the numerator, I have b squared minus 4ac. Just looks a little prettier than negative 4ac plus b squared. And wouldn't you know, when we go take the square root of both sides, our denominator was a perfect square, so the square root of 4 is 2, and the square root of a squared is a. And here we have our beloved quadratic formula that you learned the song to in freshman year. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And the freshman year we did not talk about where it came from, and now you know. First, we would like to put it in standard form, and then we can see that the coefficient of x squared is 1, the coefficient of x is negative 8, and the constant's negative 33. Now I'm lazy. I don't want to write down two negatives, so I just said, hey, the opposite of negative 8 is 8. Negative 8 times negative 8 is positive 64, so this spot, since it's b squared, is always going to be positive here. Minus 4 times a was 1 times c is negative 33, all over 2a is 1. And the square root of 196 is 14. 8 plus 14 is 22, divided by 2 is 11. 8 minus 14 is negative 6, divided by 2 is negative 3. So those are our two solutions. And yes, we could have solved this by factoring, but these first two examples are a nice, easy way to get started on what the quadratic formula is. The quadratic formula can be used to solve any quadratic, factoring cannot. So here we go again. How formula can use? A is 1, b is negative 34, and c is 289. So x equals negative b, negative negative is positive again, plus or minus the square root of b squared, and negative times negative is positive again, minus 4 times a times c all over 2a. The part in the radical, which is called a discriminant, ends up being 0 this time, so 34 plus or minus 0 is going to be 34 either way, so we'll only get one answer this time of 17. And there's a reason for that graphically. When we type it in GeoGebra, we can see that this parabola is going to switch down and touch at 17 as the only point. And once again, we're plugging into the quadratic formula. The coefficient of x squared is 1, the coefficient of x is negative 6, and the constant is 2. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And this one's going to be a little bit different because 36 minus 8 is 28, which is not a perfect square. We can simplify to 2 square root of 7. And happens to be both terms are divisible by 2, so we're going to get a final answer of 3 plus or minus square root of 7. Now we can't combine them because they're not like terms. We could get decimal approximations when we type it in the calculator at about 0.4 and about 5.6. And GeoGebra is handy to help confirm that the decimal approximations are accurate. This time we had to put it into standard form first, so I subtracted 6x from both sides, and we have a is 1, b is negative 6, and c is 13. In Algebra 1, we would have stopped here because we would have said, oh, there's no real solution, but now we know how to find the square root of negative 16. It's 4i. And 6 divided by 2 is 3, and 4 divided by 2 is 2. There's a potential on number 4 here for someone to say that B was 13 and C was 6. If you do not put it back into standard order, you will not correctly identify A, B, and C, and you will be in a world of hurt. I suspect that the reason that the value under the radical sign is called the discriminant is because it helps us to discriminate what type of answers we will get. If our discriminant is positive, we're going to get 2 real roots. If it's positive and a perfect square, we get 2 rational roots. If it's positive but not a perfect square, we get 2 real but irrational roots. If it equals 0, we saw that we get 1 real rational root, and if it's negative, we'll get 2 complex roots. Find the value of the discriminant for x squared plus 6x plus 9, then describe the number and type of roots for the equation. So we've got b squared minus 4ac. So 36 minus 36 is 0. It doesn't matter if we add or subtract 0, we're still going to get the same number, so we have 1 rational root. So we need b squared minus 4ac. So 9 minus 20 is negative 11. Since our discriminant is negative, we'll have 2 complex roots. So we need 8 squared minus 4 times a times c. So 64 plus 16. 80 is positive, but it's not a perfect square, so it's going to give us 2 irrational roots. Negative 11 times negative 11 is 121 minus 4 times 1 times 10. So I have 121 minus is 81, and 81 is a perfect square. So square root of 81 is plus or minus 9. I'm going to get 2 different rational roots. We have had 5 different methods we could use to solve quadratic equations. Graphing is only useful if an exact answer is not required, best used to check reasonableness of solutions found algebraically. Factoring is great when it works, if the constant term is 0 or if the factors are easily determined. Square root property is nice when it works as well, but it only works in special occasions when you have a perfect square. Completing the square always works, but it's kind of a lot of work, whereas the quadratic formula is slick and it will work for anything, even decimals, we don't care. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, where a cannot equal 0.